Part 6, Rehabilitation Construction Basics. While this seminar has focused on the big picture concepts of seismic rehabilitation and rehabilitation design, details of installation are equally important to the improved performance of the dwelling. This section gives a brief overview of important construction information for general rules, load path concepts, cripple wall sheathing, and fasteners and connectors. Persons installing seismic rehabilitation work will be accessing and performing work in difficult access locations, which requires attention to safety. Installers must properly prepare for these difficult work conditions, including consideration of safe work methods and required protection. Once a rehabilitation design has been developed and approved by the building department, it is important that it be installed in substantial conformance with the approved plans. Revisions to the plans, if necessary, should also be approved. Specified materials, nails, connectors, etc. should be used. Bracing length and location should not be changed except for very minor adjustments. Where specified work cannot be installed, additional guidance from an architect or engineer will likely be needed. When seismic rehabilitation work is being installed, the concept of a load path provides important guidance on completeness of the rehabilitation measures installed. A load path works like a chain that is being pulled. Each link is a load path connection. A weak or missing link will prevent a building from performing as expected. To have a complete load path for cripple wall rehabilitation, fastening or connections should be provided at every potential slip plane within the load path. The figure on the right illustrates potential weak links for cripple wall bracing. When cripple wall sheathing is added, it is important to have connections to get the load in at the top of the wall and to get load back out at the bottom of the wall. Where connection is not provided at a potential slip plane, the cripple wall bracing will not perform as intended. This condition should be corrected. Cripple wall sheathing is an important component of the seismic rehabilitation work. Sheathing should have grade stamps that can be used to verify that the specified sheathing type is provided. It is important to verify sheathing is structural rated sheathing, sheathing is at least 15/32 inches thick, sheathing weather exposure rating is either exposure 1 or exterior exposure. Installation should use the largest sheathing sheet size practical given access and restrictions of placement. Plywood is fabricated at a very low moisture content, and it is typical for the plywood to expand somewhat due to higher moisture content when installed. For this reason, 1/8 inch gaps are required at sheathing ends and edges. It is recommended that these gaps be provided not only between abutting sheathing sheets, but also between panels and abutting framing. All sheathing edges are required to fall on and be edge nailed at 4 inches on center to framing, including studs, top plates, sill plates, or blocking. Ventilation holes should be provided in each stud bay. Because it is possible for moisture to enter the stud bays, the holes provide for air circulation that can allow moisture to dissipate rather than accumulate and cause decay. It is important that the correct nail type and size be used for construction of seismic rehabilitation. Nails are typically specified by a combination of type and size. Pennyweight. Load capacities of nails are primarily related to shank diameter and therefore vary based on both size and type. This can be seen in the table above, where the diameter and capacity of 8-penny common nails vary from 8-penny box nails. If cripple wall sheathing were to be installed with box nails instead of common nails, the capacity would be less than required. CEBC provisions require use of common nails. In some cases, the common nails are required to be galvanized. It is important that nails are embedded in the framing. Nails not embedded, or shiners, as seen in this photograph, have no capacity. Nails do not split framing. Nails in split framing do not have any capacity. Split framing must be replaced. Where splitting is possible, nail holes should be pre-drilled to 75% of the nail shank diameter. Abutting panel edges must either fall on a single common framing member or two framing members, properly interconnected as shown in the CEBC Chapter A3 figure. Nails are considered to be overdriven when the face of the sheathing is fractured by the sheathing nails. Many of the nails in the above photo are overdriven. Properly adjusted nail guns will not overdrive nails. Where nails are overdriven, the capacity is significantly affected and additional nails must be provided. Sheathing edge nailing at 4 inches on center is required at the upper top plate of the cripple wall, the sill plate, sole plate of blocking at the bottom of the cripple wall, all panel edges, and edges at openings in the sheathing. In short, any sheathing edge should be nailed at 4 inches on center. In addition, sheathing should be field nailed to studs that do not fall at panel edges. This nailing controls out-of-plane buckling of the sheathing. This photo shows framing clips connecting floor framing to cripple wall top plates. In locations with limited access, use of a palm nailer is helpful for installing required connectors. Square steel plate washers are required on all new anchor bolts and recommended on existing bolts where it is possible to install them. Foundation sill plates split when shear walls are loaded in plane, resulting in the sheathing being pulled up at one end of the wall. Where sheathing is pulled up, the uplift is resisted by the anchor bolts, but this causes bending of the sill plate in its weak direction, allowing splitting at very low load levels, as seen in the right photo. Steel plate washers help to limit or delay splitting of foundation sill plates. Mechanical anchors, wedge anchors or expansion anchors, are one of the types of anchors permitted by CEBC for foundation sill plate anchorage to the foundation. When using mechanical anchors, it is important that concrete is in good shape, minimum edge distances are maintained, and manufacturer's installation instructions are followed, including required torque values. Adhesive or epoxy anchors are the other type of anchor allowed by CEBC Chapter A3. When installing adhesive anchors, strict attention to the manufacturer's installation instructions is vital to obtaining adequate anchor capacity. Very important in anchor installation is proper cleaning of the drilled hole, generally using both a wire brush and compressed air. Where not cleaned properly, adhesive anchors will fail at a small portion of the rated capacity. When installing the adhesive anchor, it is important to use all-thread rod, fill the hole with adhesive in accordance with instructions, install rod with washer and nut attached, and cure before tightening. With either mechanical or adhesive anchors, there are some common installation issues that need to be considered. First, anchors installed in split plates have little to no capacity. Where this occurs, either additional anchor bolts need to be installed into sill plates that are not split, or the split sill plate needs to be replaced. Countersinking of anchor bolts greatly reduces the bolt capacity and does not allow proper installation of plate washers. Countersunk anchor bolts should not be counted towards the requirements of CEBC Chapter A3 unless specifically approved by an architect or engineer. Bolts installed with inadequate distances between the center line of the bolt and edge of the concrete can fail prematurely, with failures sometimes occurring during installation as seen in this photo. Misalignment of sill plates and foundation is sometimes found while installing rehabilitation work. Where the edge of studs and sill plates extend a small distance beyond the edge of the foundations, a wider sill plate should be installed so that the bolt center is at least 1 inch from the edge of the sill plate. Where the misalignment is larger, an architect or engineer should be consulted to evaluate the overall capacity of the wall support. You have completed Part 6 of the educational module. Contractors, please return to the contractor dashboard to take a short quiz.